Hey, hi and welcome back. I hope that you are enjoying this training. So in previous two videos, we discussed two different methods to program the code in the microcontroller. Okay. The first one was using USB ASP programmer and the second method was using USB to UART converter. And in this video, I'm going to talk about the second method in even more detail. Okay. So in this particular video, you will get even more clarity about how exactly the code is programmed in the microcontroller using USB to UART converter. So whatever things are required in order to understand the second method, all those things I'm going to explain you in this video. Okay. So after completing this video, you will have the crystal clarity about the second method. Okay. So now let's start with this video. So now let me tell you what you're going to learn in this video. Okay. So I have actually included all those points which are required in order to understand the second method, and I'm going to discuss all those points in this video. So the first point is, what is bootloader? So bootloader is actually very important to understand the working of second method. So I will explain you in detail, not in that much detail, but I will give you an overview of what exactly a bootloader is. Okay. So that's basically the first point. Then the second point is purpose of bootloader in the microcontroller. So we will try to understand what's basically the purpose of bootloader code is in the microcontroller. Okay. Then the third point is where bootloader code is programmed in the Atmega328 microcontroller. So you know that the code is programmed in the flash memory. So I will show you the exactly where the bootloader code is programmed in the Atmega328 microcontroller's flash memory. Okay. Then the next point is how Atmega328 microcontroller boots. So once the bootloader is programmed in the microcontroller, then how exactly the microcontroller boots, or how exactly microcontroller starts once the power is provided to the microcontroller, that I am going to discuss in this point. Okay. So I will discuss two subpoints under this point. The first one is with bootloader, how exactly the controller starts with bootloader, and how exactly the controller starts without bootloader. Okay. So these are 2 points that we are going to discuss under this point. So this is how basically we are going to cover this video, and I am sure after completing this video, you will have a crystal clarity about the second method to program the code in the microcontroller. Okay. So that being said, now let's start with this video. So you already know the steps which are actually involved in programming the code in the microcontroller using USB to UART converter. So the first step is programming bootloader code using method 1, which you already know. So first the bootloader code will be programmed in the microcontroller using method 1. Then we need to remove all the connections between the microcontroller and USB ASP programmer. Then we need to connect USB to UART converter to the microcontroller, and using this converter we program the code in the microcontroller. Okay. So this is how basically the connections are going to be, and after that we need to connect the USB side of the USB to UART converter to the USB port of PC, and once that connection is done, later we open the Arduino IDE software. And once the Arduino IDE software is opened, later there will be upload button in the Arduino IDE, and using that button, we program the code in the microcontroller using USB to UART converter. So this is how basically the method is to program the code in the microcontroller, which you already know. Now let's try to understand what is this bootloader code, okay, and what's basically the purpose of this bootloader code in the microcontroller. So what is bootloader code? Let's try to understand that now. Okay. So bootloader is basically a small piece of code which executes before execution of your main code or application code. So what exactly this means? For example, let's say that you have programmed a code in the microcontroller which is responsible for blinking an LED with a delay of 1 second. Okay. So this code is actually going to be a main code or application code. And before the execution of this code, blinking LED code, there will be a small code which will execute before this particular code. And that code is actually called as bootloader code. So the code which executes before the execution of your main code, it's going to be the bootloader code. Okay. So I hope this point is clear to you. I will repeat this once again. So the code which executes before the execution of your main code, that code is actually called as bootloader code. That small piece of code is actually called as bootloader code. Okay. So I hope this is clear now what exactly bootloader is. Now let's try to understand the purpose of bootloader code. So this is basically the purpose of bootloader code. A bootloader code helps to reprogram the microcontroller with a new program over convenient interface like UART, SPI, I2C. Now, when we discussed the first method, at that time I told you that we need to use USB ASP programmer, and using USB ASP programmer we program the code in the Atmega328 microcontroller over ICSP interface, which stands for in-circuit serial programming interface. In the same way, the different microcontrollers are going to have different interfaces, and using those interfaces we actually program the code in the microcontroller. Okay. For example, in case of STM32 microcontroller, there is one interface which is called as SWD interface, which stands for serial wire debug interface. And using this interface we program the code in the STM32 microcontroller, and using this particular interface we program the code in the Atmega microcontroller. Okay. But when you are using a bootloader code, this bootloader code is actually going to help you to program the code over convenient interface. Now what are those convenient interfaces? UART interface, SPI interface, or I2C interface. Okay. So you can program the code in the Atmega328 microcontroller using these convenient interfaces. Okay. Now here I'm not just talking in context to Atmega328 microcontroller. It doesn't matter what controller you are using, whether it's Atmega328 microcontroller, or whether it's STM32 microcontroller, or whether it's MSP430 microcontroller from the Texas Instruments. It doesn't matter what controller you are using. Most of the time this bootloader code, it will be actually used to program the code in the microcontroller using the convenient interface. Okay. So I hope that this particular point is clear to you. So I will just read this line once again just to get more clarity about it. So bootloader code helps to reprogram the microcontroller with a new program over convenient interface like UART, SPI, I2C. So once you have bootloader code in the microcontroller, then you will be able to program the code over any convenient interface like UART, SPI, or I2C. So I hope that this particular point is clear to you now. Now, the code which is provided by the bootloader code which is provided by Arduino organization, that bootloader code actually allows user to program the code in the microcontroller over UART interface. So if you program the bootloader code which is provided by Arduino organization, then you will be able to program the code in the microcontroller over UART interface. And that's the reason we need to connect USB to UART converter to UART interface in order to program the code in the Atmega328 microcontroller. Okay. So I hope that this particular point is now clear to you. The first point is bootloader code allows user to reprogram the microcontroller over convenient interface like UART, SPI, and I2C. And if you program the bootloader code which is provided by Arduino organization in the microcontroller, then you will be able to program the code in the microcontroller over UART interface. Okay. So now let's go ahead. So now let's try to understand where bootloader code is programmed in Atmega328 microcontroller. Okay. Now before you understand this point, at what location the bootloader code is programmed in the Atmega328 microcontroller, you should know how exactly the memory map of Atmega328 look like. Okay. So here I'm actually talking about the flash memory. You should know how exactly the flash memory of Atmega328 look like. And in this image, if you see, this is how basically the flash memory of Atmega328 look like. It starts from this particular location, which is 0 cross 0000, and it ends at this location, which is 0 cross 3FFF. So this entire size of this flash memory, it's actually 16 KB. Okay. So that's basically, if you convert this particular value, which is a hexadecimal value, to the decimal value, then you will get that this entire size is 16 kilobytes. Okay. And after that, now, if you observe this flash memory, you will see that this flash memory is actually divided in two different sections. The first section is application flash section, and the second section is boot flash section. So this is basically the region where your application code is programmed, or for example, in simple words, if you have written a LED blink code, then that will be actually programmed in this region. Okay. So in this region, the LED blink code will be programmed. And if you want to program a bootloader code in the microcontroller, then that bootloader code will be programmed in this region. So I hope that this is clear. This is how basically the flash memory of Atmega328 look like. And in this region, the main code will be programmed, or application code will be programmed. And in this region, the bootloader code will be programmed. Okay. So when we discuss the, first method using, I told you that we need to program the bootloader code in the microcontroller using USB ASP programmer. So when we are using this particular method to program the code in the microcontroller, bootloader code in the microcontroller, in that case, that USB ASP programmer, it's actually going to program the code in this region, because this region is actually the bootloader region or bootloader flash section. And that's the reason this USB ASP programmer, it's actually going to program the bootloader code in this region. And we discussed that this bootloader code will be programmed in the microcontroller only once. Okay. So that's basically the point. I hope that it's clear now where bootloader code will be programmed in the microcontroller. Okay. So now let's go ahead. So once again, I will explain you with the help of images. We need to connect this side to the USB port of PC. Then we need to connect these all connections, ICSP connections to ICSP pins of microcontroller. And once that is done, later we are going to use AVR-DUTE software. And using that software, we are going to program the bootloader code in this particular region, okay, which is bootloader flash section. I hope this is clear now. Okay, so now let's go ahead. So now let's try to understand how exactly Atmega328 microcontroller boots. Okay, so there are actually two scenarios here. The first scenario is when the bootloader code is present in the microcontroller, and the second scenario is when the bootloader code is not present in the microcontroller. Okay, so let's try to understand these two scenarios now. So when the bootloader code is not present in this bootloader flash section, it means what? We are actually using the USB or USB ASP programmer to program the code in the microcontroller. Okay, so when we are using USB ASP programmer to program the code in the microcontroller, and once the program is programmed in the application flash section, in that case, straight away from this particular location 0x0000, it's actually going to start executing the code line by line. Okay, so it's going to fetch the instruction from each address, and line by line it's actually going to execute the code from the application flash section. So this is actually the case when the bootloader code is absent. Okay, now let's try to understand the second scenario when the bootloader code is present in the bootloader flash section. Okay, so you already know that we are going to program the bootloader code provided by Arduino organization in this particular region. So let's try to understand how exactly this particular code, or when the bootloader code is programmed in this controller, in that case how exactly the microcontroller boots, or how exactly microcontroller starts. Okay, so when the power is provided to the microcontroller, or when the microcontroller is reset, in that case, first of all, it's actually going to execute the first instruction which is there on this particular address. And in that first instruction, there will be actually a command to jump to this particular address. So once the bootloader is programmed in this microcontroller, then the first thing that microcontroller is going to do, it's actually going to jump from 0x00 location to this particular location, which is actually the location from where the bootloader code is actually programmed. So once the control comes to this particular region, then the code which is programmed in this region, it will actually start executing. Now, what is written inside this bootloader code, let me try to explain you that now. So when the code is executing, when this bootloader code is executing, what it's trying to do, it's actually going to check the RX pin of the UART interface. Okay, so it's going to check the RX pin of UART interface. The reason is we have actually used the USB, USB to UART converter we have connected to the RX and TX pin of the microcontroller, and we are going to program the code in the microcontroller using USB to UART converter. So the USB side of the USB to UART converter will be connected to the PC, and the RX TX pin of the USB to UART converter will be connected to the TX and RX pin of the microcontroller. Okay, so this TX pin of USB to UART converter is connected to the RX pin of this microcontroller. Okay, now when you are programming the code in the microcontroller, in that case, this bootloader flash section, the code which is written inside this bootloader flash section, it's actually going to monitor the RX pin, and it's going to check whether the predefined sequence of bytes are received or not. If the predefined sequence of byte is received over the RX pin and those bytes are compared or validated by this particular program, then this particular program is actually going to understand that external programmer or the right programmer is actually connected externally. Okay, and once that is confirmed, or once the handshaking is done between this code and the USB to UART converter, then whatever data this USB to UART converter is going to send over the RX line, all that data will be programmed by this particular code inside the microcontroller. Okay, so this code is going to take that data and it's going to program that data in the microcontroller, and this data is actually nothing but the code which you want to program in the microcontroller. Okay, for example, if you want to blink a LED which will be blinking with a delay of 2 seconds, then that code will be sent by the USB to UART converter over the TX line, and it will be received by the RX pin of the microcontroller, and then this bootloader code is actually going to program that code in the application flash section. And once that is done, once the entire code is programmed in this application flash section, then this code is actually going to jump directly to this particular location, which is 0x00, and it's actually going to start executing the code which is written in this application flash section. Okay, so I hope that this point is clear to you, how exactly the microcontroller behaves once the bootloader code is programmed in the microcontroller. Now in this case, the USB to UART converter was connected here, and in case the USB to UART converter is not connected, then what will happen, this code is again going to do the same thing. It's going to check, or it's going to monitor the RX pin of the microcontroller, and if it didn't receive the predefined sequence of byte over the RX pin, then this code will understand that no external programmer is connected over the RX pin, and as a result, it has to jump from this location to this particular location, which is 0x000, and it's going to execute the old code which is already there inside this application flash section. Okay, so this is how basically the controller boots, or controller starts when the bootloader code is present inside the microcontroller. Okay, so I hope that you have now a crystal clarity about both the methods that we discussed. Now let's go ahead. So now let me explain the same point with the help of this particular image. So when with the help of Arduino IDE, we are programming the code in the microcontroller. The code is actually going to travel through this USB to UART converter over the TX line, and it will be received over the RX pin of the microcontroller. And once the code is received, then the bootloader code which is there inside the microcontroller, it's going to program that code in the application flash section. Okay, so I hope this point is now clear to you. Now let's go ahead. Now here you will have a question, why Arduino organization choose the UART interface to program the code in the microcontroller instead of using the ISP interface or ICSP interface. Okay, so let's try to understand this point now, because this point is actually very important. The reason is they actually wanted to create something simple, okay, which can be used by people who are getting started with the hardware designing or programming, okay. And in order to keep the thing simple, they actually reduced the hardware complexity, and in order to reduce the hardware complexity, they actually decided to use the bootloader code in the microcontroller. Because by using the bootloader code, it's actually going to give some advantages, because by using the bootloader code, there will be certain advantages. And what are those advantages? Let me talk about that now. So the first advantage is, if you are using a bootloader code to program Atmega328 microcontroller, then you don't need a programmer like USB ASP to program it, okay. So we don't need the USB ASP programmer at all to program the code in the microcontroller. So this USB ASP programmer will be completely eliminated once you have the bootloader code in the microcontroller, okay. However, as I told you, we are going to need this USB ASP programmer only once to program the code in the microcontroller. So the second point is, by writing an appropriate bootloader code, we can program the code in the Atmega328 microcontroller over UART interface. So you already know that we can actually use multiple interfaces like UART, SPI, I2C. But now that the bootloader code which is provided by Arduino organization, it is actually capable of providing the microcontroller over UART interface. So that's why I have actually written here UART interface, okay. Now, still from this particular point, you might not be getting a good clarity about what's basically the advantage of using a bootloader in the Atmega328. But from this point, now you will get clarity about it. So with bootloader code, we can use USB to UART converter to program the Atmega328. Also, we can use the same hardware, to send the data to the computer. So I hope that now you got the advantage of using the bootloader code in the microcontroller. So here, with the help of bootloader code, we are able to bypass, or we are able to remove this USB ASP programmer. So we just need a single hardware to program the code in the microcontroller, and by using the same hardware, we can actually communicate with the computer, or we can exchange the data between the controller and the between the computer and the microcontroller. So I hope that this particular point is clear to you. And then the last point is, so with same hardware, we are able to accomplish two tasks, as we already discussed. The first one is to program the microcontroller. So we are able to program the microcontroller using USB to UART converter. And the second one is to send and receive the data to and from the terminal window on computer. So this is how basically, with the help of single hardware, which is USB to UART converter, by using a bootloader, we are able to accomplish two different tasks, okay. So I hope that this is clear, and I also hope that every single thing that we discussed in this entire video is now clear to you. If you still have any kind of doubt, if something is not clear to you in this particular video, I understand that some of you might be having some questions related to this particular video. If you have questions, then definitely do not hesitate to ask me those questions. Ask me questions and I will help you with that, okay. Alright, so that's what I wanted to tell in this video. I hope that every single thing discussed is now clear to you. Now I will see you in the next video, which is about programming bootloader in the Atmega328 microcontroller, okay. So in next video, we will see the process to program the bootloader in the microcontroller. So I will see you in the next video now.